Well, good morning, Royal High School Woodshop. Today's machine of the day is the combination sander. Well, sanders are an integral part of woodworking. There's a variety of them. We've looked at several. There's no way around it. You got to use a sander, but sanders need to be used correctly. I've seen lots and lots of really nice projects just completely ruined by folks going over and messing stuff up on a sander. So we want to be very careful when we choose to use a sander and how we use it, because it can so quickly change my pieces and the shape of my pieces. One thing that's helpful to remember is pieces fit into projects best when they are square and at a right angle. If I just stick this board up against this sander and start sanding it, I have no idea what angle I'm actually sanding on the end. And then when I go back to stick it in my project, it doesn't fit. I just made an angle, or I rounded the end, and that's not what it was supposed to be. So I want to be very cautious when I sand. I limit my sanding to things that are completely necessary, and that's it. If I just want to make something smooth or whatever, I'm going to do that with hand sandpaper, and I do it on the face of a board, the surfaces of a board. Generally, I don't do a lot of sanding on surfaces that are going to be joined together. Those are cut on saws. Because I'm holding it stably against a fence or a table, it's going to cut at a right angle. I generally would never want to come back and try to sand my chop saw cut, for example, let's say. So the sander is made up of several parts. The one that we tend to use the most here in the wood shop is the belt sander. This is the belt sander. This is a 6-inch by 48-inch belt sander. We start right here with a table, right? The sanding table. And the sanding table actually has a groove in it, so I could put a miter gauge. That, if I wanted to hold my piece at a perfectly 90-degree angle, that would be the best way to do it. Put a miter gauge in here, use that to help control how the board was going to touch the sandpaper. Now in the back here, there's a guard. The guard can be taken off if I have to use this top barrel as a way to sand the inside of a curve. However, that's not the most accurate way to do it. So since we have a spindle sander in our shop, we're not going to take the guard off and use this essentially spindle up here to do our sanding. It's way too inaccurate. We have way too many potential problems if we take this off. Now, if you were at home using this in your garage and you didn't have a spindle sander, that's definitely a way to sand the inside of a curve. That's an option. Over here on the side, we have this little lever, right? This is the tension release lever. That's going to release the belt, right? We'll call it the belt tension release lever, so we can make it really complicated. The belt tension release lever. Now with that belt lever raised up and the tension off the belt, I can very easily slide the belt off so that I can change the belt to a new one. I slide the belt back on there, push that lever back down, it puts tension back on the belt. I'm ready to sand. When I turn this on, I'm just going to turn it on and off. So that since I put the new belt on, I want to give it a chance to sort of center itself, find where it's supposed to be. I don't want to flip it on and have it go way too far and start getting destroyed on the metal parts over here. So when I put a new belt on, I'm always going to just see how it goes, and then once it's found its resting place, then I can go back and start my sanding. Down here I have the table release handles. So that is going to release the table. If I wanted to sand an angle on a sander, I don't lift my board up off the table. Instead, I adjust the table angle to whatever degree. There's a protractor on most tables or most things that will tilt. They generally come with a protractor, so I can tell right exactly what angle I want to be at, and then I tighten the table back up. If I put that at a 45-degree angle, now I'm ready to sand my 45-degree angle on the board. I would never do this. I never want to go like this and try sanding. The board always has to be resting flat and secure on a table before I touch it against the sandpaper. So the only way to sand an angle is to tilt the table first and then do my sanding. Now, In this particular sander, what I notice is there's no protractor. So how would I figure out what angle I'm at? Well, first of all, I would use a tri-square, and I use a tri-square to set it at 90 degrees. And then if I wanted to set it at any other angle, I would use one of the other tools that we talked about that helps me with angles. What was that called? The sliding T-bevel. I'll take my sliding T-bevel, I'll use a compass, or I'll use a protractor to set the sliding T-bevel at whatever angle I want, and then I'll hold the sliding T-bevel up here and adjust my table. Over here, there's another little device. This is the tracking knob. The tracking knob. Now, tracking is, right, let's see, what's a good example? The bandsaw, we talked about tracking. The bandsaw blade has to run right in the middle of the wheel that it's turning on. Your VCR, if you have a old school VCR where you have a VCR tape that goes in, those tapes have a little tracking button, and the tape moves up and down and it finds the exact spot so it's reading very well and you see the picture the best on your TV. That's tracking. It moves the tape, the VHS tape, back and forth and gets it in the right spot. Same thing is true here. If I'm not careful and the belt starts to move to one side, as the belt moves, it's going to run into the metal housing that makes up this sander, and as the sandpaper rubs against the metal housing, it's going to start to damage it. Both the sandpaper and the metal housing will get destroyed. So this is the tracking adjustment knob or handle. And when I put a new belt on, especially if I notice that it's not running directly on this little barrel up here, then I would adjust this handle and move it back and forth until it's right where it's supposed to be. Then I lock it in place and I'm ready to sand. Down here, there are two release latches, and these are for the sawdust. So down in here is a metal safety guard, and if I loosen those up, it allows me to open that up. Not only can I get the sandpaper off to change it, but I could also vacuum out in here if there's a lot of sawdust collected in there. When I'm done, I want to make sure I put those back so that I don't have any exposure to the moving parts. So that really makes up all the pieces on the belt sander. Let's take a look at, I'm going to show you the disc sander that's also attached to this combination sander. Now, a combination sander means that we are combining two sanders on one motor. So here's the other sander. This is a disc sander. We have a big one here in the shop, a big disc sander, a 20-inch disc. This is about a 8-inch disc. Now notice there's no table here and there's no sandpaper on it. So all those same rules would apply to the disc sander that apply to the belt sander, as well as one additional one. On a disc sander, you always sand on the downward side of the disc, not the upward side, right? If this is a piece of sandpaper that's spinning, half of it's going up, half it's going down, you always sand on the downside. Now notice there's no sandpaper on here. So if this was in my garage, I would put the sandpaper on there and use it, because it's one person using the sander, and I can only sand on one of the sanders at a time. But in our wood shop here, because there's multiple people, what we don't want is we don't want one person standing here sanding on this sander and one person sanding on this sander. That's going to put too much strain on the motor right here. And it gets us in too close of a proximity to one another where somebody could get injured. So in the Royal High School wood shop, we don't use this disc sander. We use another one that's off in this little collection of sanders. But I want you to see how that works. Now from this angle, you can see both the on and off switch as well as the motor, right? And so you can see the motor is driving this sandpaper over here, and then it's driving this disc on this side. Great feature, especially if I'm going to put this in my garage and there's one person using the sander. But in a classroom where we're using we got several people working on this at the same time, or wanting to work on it at the same time, We're gonna leave this one off. All we're gonna use our combination sander for is the belt sander. So when I'm ready to sand on this sander, everything is set up correctly. I'm gonna put my piece of wood flat on the table. And then I'm gonna, with it secured on the table, then I can touch it up against the moving sandpaper. So there are some safety rules that we always follow. Number one, right? Like we've seen on every other machine, I always make sure I have my glasses on. No long hair and jewelry, right? So if I have jewelry or long hair, I have to address that. So in the case of my jewelry, hoodie strings, lanyards, earbuds, all of that kind of stuff. It's got to be tucked into your shirt where there's no possible way it can fall out. For long hair, I have to have that long hair up in a way that it's not going to get in here, because for many of you, if you're standing here working, your long hair is right here. It's literally inches away from the sandpaper. And if it gets stuck in there and pulled in, it's going to pull you down into the machine as well. So I got to address that. My fingers should never be closer than 1 inch from the sandpaper, right? So a much safer machine, but I want to keep my fingers at least 1 inch from the moving sandpaper. Now, one of the big safety issues on sanders, and we mentioned this before on the spindle sander, is the space between the table and the sandpaper. On our spindle sander, we had a throw plate that we had to use to close up that space. On a disc sander or on a belt sander, there's no throw plate here. It all has to do with the adjustment of the table, and when you get your table adjusted and locked, is it tied up against the sandpaper? If I have a gap between the table and the sandpaper, and I'm trying to sand tiny little pieces, and the sandpaper is turning down like this, what can happen is that. And the little tiny piece disappears down into that opening. If my hands are on it, when it goes, it's gonna pull my hands up against the sandpaper. So one of our rules is no small materials. Now, what is small material? Well, that kind of depends, right? It depends on the comfort level and the safety of the student. You have to make a decision. So if I sand this board, it's about 8 inches long. If I sand it like that, it's plenty long. I don't have any problem. But if somehow it flipped up like this, now it's small enough that it can disappear down into that gap. That's too small. That's a problem. So in this case, it depends on how I'm sanding it. If I sand it this way, it's perfectly acceptable. If I were to need to sand it this way, too small, can't do it. I have to figure out another way to do it. So again, our safety rule, no small material. But really, each individual student has to be thinking about that as they work on their project, right? If you're doing a different project, then the sizes of your pieces are different than mine. You have to figure that out. So that's my setup. Those are the safety rules that I really want to make sure I'm following. Now I'm ready to sand. So it's time I'm gonna turn it on first before I put this up against there. I always want the machines up to full speed before I start working on them. And I work on sanding it. Now notice as I put this board up against the sandpaper, I kept it moving. That's another rule. It's not necessarily about safety, but it is an important rule on a sander. Whenever I put wood against sandpaper, I want to keep it moving. If the wood gets too hot, especially on the end grain, and in this piece, I'm going from in grain around to side grain, in grain around to side grain. If it gets too hot, the end grain will burn. Hard to burn the side grain, but the end grain will burn if I get it too hot. How would I get it hot? By just holding it in one place and not moving it. So you noticed once I put the piece of wood up against the sandpaper, I kept it moving at all times. And by doing that, I eliminated the problem of burning, or at least tried to decrease that. Sometimes it's hard to get away from it, but you can at least decrease the chances of it burning as much as possible. Now I could also sand an angle on this board. If I wanted the angle on there, I can hold it like that and put a bevel on it. And I have started to sand a bevel on this board. Now notice again, I'm still moving. I don't stop. I'm not using a miter gauge, right? So this is one of the machines where I can do all this work freehand. Why? Because the sandpaper is going down towards the table, I'm not going to have a kickback. So I can be freehand here. Now, if the bevel needed to go this way, remember, one of our safety rules, you never lift the board up off the table to sand. That's a bad idea, because I go to touch it on there, it's going to want to slam it down on the table. The sandpaper is moving downward. If it slams it down on the table, it could slam it on my fingers. If everything moves, I could also end up with my fingers in the sandpaper. So I never lift up a piece of wood off the table to sand. If I want to put a bevel this way, I have to adjust the table first. Set the table at the desired angle and then sand. How do I know what angle this is at? Well, remember, because there's no protractor on this particular sander, I would have to get my protractor out of the closet. I'd get my sliding T-bevel, set the sliding T-bevel at 37 degrees, and then put it up against here. And there is the bevel that's being sanded on the end of the board, right? Again, I'm keeping it moving. And if I really needed it to be perfectly straight across there, then I would probably want to get my miter gauge and stick it in there as well to just help make sure the piece wasn't doing any kind of movement. Well, that's a look at our belt sander. I'm going to show you the disc sander, but for the disc sander, we need to go to a different machine. We're going to go to a different machine because we're not using the disc sander here. So I'll show you how it works, but I'm going to show you on a separate machine. So here is our big 20-inch disc sander. This is a giant disc sander, and it's very handy, does great work. One big serious thing, and that is a 20-inch disc sander can throw a board up into your face just like that, and very hard. So as we talk about the disc sander, the main safety thing we need to remember is you always sand on the downward side of the disc. The disc, right, is a round circle that's spinning. So half of it's going down towards the table, half of it is lifting up off the table. And as much as you can possibly make it happen, you want to keep the piece you're working on the downward half of the disc. Don't touch the upward side of the disc. Sometimes if I have to cross over, make sure you are holding on for dear life to that board, and you should get away with it. If you are unaware of what you're doing, if you're being timid, if you're not paying attention, and you touch the board on the upward side, there's a very good chance that it will flip that board up off your face to the ceiling. So that's a big part that we want to be concerned with. Now, our disc sander, we've got our sanding table, and it's got a miter slot in it. So we can put a miter gauge in here if we want to really hold that piece at a certain angle and sand it so that it's very accurate. We can do that. The vast majority of sanding on a disc sander gets done freehand, right? But if we needed something extremely accurate, we could do that because our disc sander has a slot for a miter gauge. Our disc sander also has a safety guard. Now, because the manufacturer realized sometimes the project is bigger than what will fit on here, they made this safety guard so that it could move out of the way. But I only move it out of the way when it's absolutely necessary, right? Having that guard on there means I'm not going to accidentally bump the edge of the sandpaper with my fingers. When I sand, I want to be on the downward side of my disc here. I don't want to sand up against the edge. Stay away from the edge if possible, because then you're going to have, generally it's going to lead to making little grooves and marks on your stock. Now here's one more sander I want to show you. This is called a horizontal edge sander. It's got about a 4-foot sanding belt here that we would use, and all the same safety rules apply to this sander that apply to all the other sanders we've looked at. There's one additional safety rule that we want to make sure we're aware of. So the horizontal edge sander, the sandpaper is moving horizontally like that, in this direction. When I put my piece of stock up against the sandpaper, if I'm not aware of what's happening, I'm not thinking about what I'm doing, it's very likely that that piece of stock would want to take off across the classroom like that. So the manufacturer has put a fence here, down at the far right-hand side of the horizontal edge sander. And when I put my stock up against the horizontal edge sander to do some work, I start by securing my stock to the table like I do in all the other sanders. However, the second thing, in the rest of the sanders, I would at this point push the stock up against the sandpaper. Step 2 on the horizontal edge sander is to put the stock up against this stationary fence. Like that. Now the stock cannot get shot out of my hand off across the classroom. If there was any chance that it could move off to the right, it can't do it because it's held securely up against this fence. Now, and only now, am I ready to take the piece of stock and gently push it up against the sandpaper. This is an oscillating edge sander, so like the spindle sander, it moves up and down while it's running. That's just helping to spread the sanding out over more sandpaper so that we don't just waste a giant piece of sandpaper. Let me go ahead and take a second and show you what it looks like to put a piece of stock up against the horizontal edge sander. So I would repeat that process as many times as necessary as it takes to get this perfectly flat and smooth. And it's very simple, but that extra little step in there really helps to keep the piece of stock from getting shot off the sander. Back here in the back corner, we've got two 1-inch belt sanders, and they operate exactly like the other belt sanders. All the same safety rules apply. I use them just for specialty items and in special circumstances where the other sanders are just way too big, and I just need this one little tiny bit of sandpaper, and that's it. That's what we would use them for. Let me show you real quick what it looks like to work on. All right, it's as simple as that. Just keep my fingers away, keep my baggy clothing, my hair away from any moving parts here. Keep the piece of stock moving along the sandpaper, and works great. Now, as is true on all of our sanders, there's a few items that we want to make sure that we consider when using any of the sanders. So, as I've mentioned, a safety factor on a sander is the space between the table and the sandpaper. So we always want to make sure that we're not sanding small material. Remember, small material really has to be considered at each instance, right? Because if I hold a board one way, it could be fine, and if I turn the board the other way, it now becomes too small based on the gap between the sandpaper and the table. So one of our safety rules is no small material, and you just have to make a good judgment call on that. We want to make sure that we keep our fingers about 1 inch away from the sandpaper. So our safety margin on a sander, on any of the sanders, is about 1 inch. We just want to keep our fingers back.
if we get to within 1 inch, we probably ought to go to a different machine or use a different technique. So we have a 1 inch safety margin on all the sanders. You always want to keep your fingers, any kind of jewelry or clothing, long hair, away from any moving part on a sander. Sander's not going to cut your hand off, but a sander will sand your skin off. Keep your hands and your body away from the moving parts of a sander until it stops moving. Anything that's spinning is a danger for long hair, so we want to make sure we've taken care of our long hair as well. I always need to have on my glasses. Any of the sanders are going to throw up all sorts of material. The disc sander in particular could throw the piece of wood up into my face if I happen to cross over the center line. Remember, we want to sand on the downward side. And we have an eraser that sits around here at the sanders, and this takes sawdust and sap and stuff off of the sandpaper. So every now and then, if you're going to be using some sandpaper and you notice that there seems to be a lot of sawdust built up on it, I can turn the sander on, and then I'm going to just draw this rubber eraser essentially along the edge of the sandpaper, and it will clear off or clean off as much as it can. And that just gives me sandpaper that's in better condition to do the work that I'm trying to do. Always remember that we shouldn't be using a lot of force. Usually if we're having to push too hard to get the sandpaper to actually work, it's telling us that the sandpaper is probably worn out, or it could just be the wrong sandpaper, right? We might have a really fine sandpaper on here and the job you're trying to do requires a really rough sandpaper. So what we need to do is not push harder, but change the sandpaper. All right, well, I think that pretty much wraps up our look at all the sanders. So I hope you've enjoyed getting a chance to see the sanders at work, and I know that you're going to get to use them very shortly. So enjoy that, and look forward to seeing you next time when we look at another one of the machines.